Hello students, I am GUNVANT PATEL from Logic Institute and today I am with the next lecture of electrostatics. In this lecture, we will discuss about our next topic, that is potential energy of dipole. So potential energy, you already know that potential energy is some kind of stored energy, and whenever the work is done on particular object, the energy is stored in the form of potential energy, kinetic energy, and so many forms. And here we are discussing about the potential energy of dipole in external electric field. Potential energy of dipole in external electric field. External electric field. We all know about the dipole. आप सबको डाइपोल के बारे में पता ही है. प्रीवियस लेक्चर्स में हमने डाइपोल के बारे में पढ़ा है. डाइपोल इज नथिंग बट अ वन काइंड ऑफ सिस्टम ऑफ two equal but unlike charges separated by some finite distance, and that system is known as electric dipole. And here, whenever the dipole is placed in external electric field, then some kind of energy is stored in the dipole. Let us see. This is uniform electric field, and in this electric field we are placing a dipole, and we also know that whenever the dipole is placed in external electric field, it experiences some kind of torque. Let us consider here E is uniform electric field, and this one is a dipole which is placed in this external electric field. This one is minus q charge plus q charge. Understood or not? And consider the dipole moment is P, which makes an angle with the electric field is theta. Is it very simplest? So here we can say that the torque, हम क्या करेंगे यहाँ पे, ये जो डाइपोल है इट इज इन स्टेबल कंडीशन वेन एवर द टॉर्क इज जीरो. टॉर्क जीरो तभी हो सकता है वेन एवर P and E both are in same direction, that is parallel, and in that case torque tau is equals to PE sin 0 and that is equal to 0. मतलब हमें ऐसा कंसिडर करना है कि इनिशियली टॉर्क जीरो है, और जब आप वही पर्टिकुलर डाइपोल को थीटा जितना रोटेशन देंगे, जब भी हम इसको थीटा जितना रोटेशन देंगे, जैसे मान लो हियर वेन एवर P इज पैरेलल टू E, इन दिस केस यू कैन सी दैट द डाइपोल इज अरेंज्ड इन द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड. ऐसे होगा, दिस वन इज माइनस क्यू चार्ज, दिस वन इज प्लस क्यू चार्ज, एंड वेन एवर यू रोटेट बाय सम एंगल यू हैव टू डू सम काइंड ऑफ वर्क. और जब भी वर्क डन करना पड़ेगा, इट मीन्स देयर इज सम काइंड ऑफ एनर्जी स्टोर्ड इन दिस डाइपोल. ठीक है ना बच्चों? तो यहाँ पे बहुत ज़्यादा सिंपल सा हो जाएगा. सो वी विल राइट द डाइपोल विथ डाइपोल मोमेंट P is placed in external electric field. External electric field. Then the torque experienced by this dipole is tau is equals to PE sin theta. It's very simple. We already know about this formula, tau is equals to PE sin theta. Now we will considering the work done to rotate the dipole from angle theta 1 to theta 2, the work is done is W is equals to integrating from theta 1 to theta 2, and that is tau dot d theta. Likewise, whenever we displace, here we are rotating, so we have to take angular displacement, and we know that the cause of rotational motion is torque, that's why tau dot d theta. जब भी आप linear motion होता है तब हम लोग क्या करते हैं, x1 to x2, and that is f dot dx. This is linear displacement, this one is force, because cause of translational motion is force. Here cause of rotational motion is torque, that's why we are taking torque. Very simplest. So this work done is stored in the form of energy. तो हम क्या करेंगे, we will put the value of torque and integrating this expression. Torque is equals to P sin theta, where P is dipole moment, E is external electric field, and theta, that is angle between P and E. It's very simplest. So here P and E are constant, so we are taking as a common. Okay, what is the integration of sin theta? The integration of sin theta is minus cos theta, and the limits are theta 1 to theta 2. It's very simplest. Put the upper limit. Remember that the integration of sin theta, that is what, minus cos theta. Now minus PE, take minus as common. First put the upper limit cos theta 2 minus, then put the lower limit cos theta 1. Clear or not? It's very simplest. So this is the work done. This work done is stored in the form of potential energy. So लिखेंगे this work done is stored in the form of potential energy. This work done is stored in the form of potential energy. So that's why potential energy U is equals to minus PE cos theta 2 minus cos theta 1. In the stable condition, we know the value of cos becomes 0 at pi by 2 whenever the theta becomes pi by 2. अगर cos का वैल्यू 0 हो जाएगा, in that case the energy becomes 0. तो हम लिखेंगे for conventions take theta 1 initial angle is 90 degree and theta 2 is equals to theta. Let us considering we are rotating the dipole from 90 degree to theta, because at 90 degree the value of cos is 0. अगर cos का वैल्यू 0 होगा तो एनर्जी 0 हो जाएगा. That means for conventions take theta 1 equal to 90 degree and theta 2 is equal to theta. It means we are rotating the dipole from 90 degree to theta. So that's why U is equals to, it's very simplest, PE cos, in place of theta 2 we will write theta minus cos 90 degree. This cos 90 degree equals to 0, so U is equals to minus PE cos theta. Cos 90 is 0. So this is the potential energy. It is the expression for potential energy of dipole in external electric field which is rotated by angle theta. It's very simple. क्लियर और नॉट? नाउ डिस्कसिंग सम केसेस अबाउट इट. अब आप बोलोगे कि ये जो डाइपोल है वो स्टेबल कब रहेगा? whenever the dipole is in its most stable case and whenever it is in most unstable state. ऐसा कब हो सकता है? तो एकदम सिंपल सा है, जब भी किसी पर्टिकुलर ऑब्जेक्ट का एनर्जी मिनिमम हो जाएगा, दैट टाइम वी कैन से दैट इट इज इन स्टेबल कंडीशन. और जब भी वो उसका एनर्जी मैक्सिमम हो जाएगा, दैट टाइम वी कैन से दैट इट इज इन इट्स अनस्टेबल स्टेट. सो दैट्स वाई. अब आप सिंपल सा सोच सकते हो कि कॉस्ट का वैल्यू मैक्सिमम, अगर कॉस्ट का वैल्यू मैक्सिमम होता है 1, अगर कॉस्ट का वैल्यू 1 हो गया, दैट टाइम u बिकम्स माइनस पी विच इज मिनिमम वैल्यू ऑफ u. बिकॉज नेगेटिव में जितना आप वैल्यू लार्ज होता जाएगा, जैसे मान लो -3 इज लेस देन -2, सो वी कैन से दैट -3 इज मोर स्टेबल देन -2 बिकॉज ये वैल्यू कम है. तो यहाँ पे हम वही लेने वाले. सो वी विल टेक लाइक दिस case 1. If P and E is parallel, if P and E is parallel, that is theta is equals to 0 degree. ऐसा कब होगा? Whenever the dipole is aligned in the direction of electric field. This one is electric field and this one is dipole. This one is minus q plus q. This one is p. Whenever the p and e both are in same direction, that is p is parallel to e, in that case theta becomes 0. If theta becomes 0, that time energy u is equals to, we can say that minus pe sin 0, pe cos 0. In place of theta we will take 0. So pe cos 0 is 1, so that is minus p. This is the minimum value of energy. अगर किसी ऑब्जेक्ट का एनर्जी मिनिमम हो जाएगा, दैट टाइम the particular object is in its most stable state. So that's why this is the condition for, we can say that in this case the dipole is in its most stable state. Second case, case number 2. If P and P and E are anti-parallel. Anti-parallel मतलब mutually opposite. और जब भी whenever they are anti-parallel, the angle between them is then theta becomes pi radian, that is 180 degree. Pi radian we know that is 180 degree हो जाएगा. ठीक है ना बच्चों? जब भी वो पैरेलल था तो एंगल 0 था, एंड दिस इज इन दिस केस its energy becomes minimum, and if its energy becomes minimum, it is said to be in most stable state. And whenever P and E are anti-parallel, that is they are mutually opposite, then the angle between them is 180, and in this case energy becomes, देखो ये केस में कुछ ऐसे दिखेगा, this one is electric field and dipole align in such a way that the dipole moment, this one is minus q, this one is plus q, so dipole moment is opposite to E. Dipole moment is opposite to E, and in that case energy U is equals to minus PE cos pi. Pi, that is 180, and cos pi is equal to -1, so minus plus PE. This is maximum. This is what? Maximum. And whenever the energy of particular object becomes maximum, it is said to be in most unstable state. So we can say that in this case the dipole is say in its most unstable state. Most unstable state. It's very simplest. And the last one, that is case number 3. If P is perpendicular to E, then theta is equals to 90 degree and the energy U is equals to minus PE cos 90, and cos 90 is what? 0. It's simplest. ठीक है ना बच्चों? तो these 3 cases are very important. ठीक है ना बच्चों? This is the potential energy of dipole in external electric field. Here the external electric field is uniform. If it is non-uniform, that time also we can apply this kind of formula. ठीक है ना बच्चों? It's very simplest. Please copy down.